if you recall from the previous sections, the logarithmic form and the exponential form to write an equation, and we could convert between the two. So the way to solve an exponential equation is to write it in logarithmic form. The way to solve a logarithmic equation is to write it in exponential form. And hopefully one of the forms will be easier to solve. And so you just convert from one form to the other until you get it to a form where you can actually solve the equation. Page 482. Solve each exponential equation using like bases. Problem number 6. 32 to the power x plus 2 is equal to 2 to the power 7x plus 12. I can write 32 as 2 to the power 5. And so I have a common base of 2. So this is equal to, by the properties of exponents, I have a base to an exponent, multiply the exponents. So I'll multiply 5 times x plus 5 times 2 is 10, equaling 2 to the 7x plus 12. The same base, 2, and these exponents are equal. Since the exponential function is injective, then the exponents must be equal. So I'll set each exponent equal to each other and solve for x. And so I have that. Subtract 5x from both sides of your equation. So I have that 2x is equal to, subtract 12 from both sides of your equation, negative 2. And that is your answer. Let me do problem number 34. Solve each exponential equation using logarithms. Give your answer in decimal form, rounding to 4 decimal places. So let me notice that there's no way to get the same base without using logarithms. So there's no common base between 8 and 11. So let me take the logarithm of both sides of my equation. Now, I can use any base I want, but again, since we always like to use the natural logarithm, and so I'll just use natural logarithm. So I'll take the ln of both sides of my equation. And again, it doesn't matter what base you use, but you know, we've always used natural logarithms past 1970. So let's bring down the exponent out in front using the properties of logarithm. I can just simplify this. Now take, now divide both sides of your equation by ln 8. And so I have that x is equal to plus or minus the square root of ln 11 over ln 8. And that is your answer. Wait. Now, you should check to see if this would work, but you're squaring, so it's an exponential. And so for an exponent, as long as you did the algebra correct, it should work. Oh, and they told us actually to write this. They actually don't like they don't want the exact answer. They want the approximate answer. So let me give the approximate answer. And so let me plug this into my calculator. Okay. And so X is approximately 1.0. There it is. Let's see if I can. Okay. 1.073845367. So X is approximately 1.0738. And that is your answer. Okay. Let's do the next. Solve each equation. If an answer is not exact, oops.
I have a question.
Yes.
So whenever we square root like a log or like the natural log, it's always going to be positive, the answer? Or is it going to be plus or minus?
If you have, so you're asking about the square root. Ooh. Are you asking about that?
Yeah.
Oh, that was a typo.
Oh,
So that was purely a typo. Thank you. That was a typo. It was plus or minus. That's a horrible typo on my part. It's plus or minus. Yes. No, it could be. It's because it's a square root property. So it could be plus or minus 1.0738. Sorry about that. Okay. Solve each equation. If an answer is not exact, give the answer in decimal form, round to 4 decimal places. Okay, so let's take ln of both sides of this equation. There's not much I can do with this guy. Sorry. Okay, it's finally moving. So 3 to the x and 2x. So let's take ln of both sides of my equation. So ln. Well, this is going to be let's simplify each side of this equation. Since I have ln of a product, there'll be the sum of the ln, so ln2 plus. I'll bring the exponent out front, so x ln3 equal. I'll bring the exponent out front, 2x ln6. Let's try to simplify this. So let me subtract x ln3 from both sides of my equation. So I have ln2 is equal to 2x ln6 minus x ln3. These are not like terms, so I can't really do anything with them. I can, but nothing nice. Let me factor out an x. So 2 ln6 minus ln3. You could simplify this to ln12, but I'll just leave it like this. Let's divide both sides of my equation. Let's move this down a little bit. Let's divide both sides of my equation by the 2 ln6 minus ln3. So x is equal to ln2 over 2 ln6 minus ln3. And, well, I'll just leave it in that form. Oh, I guess, again, they don't want, so I'll plug this into my calculator. You could actually write this as log base, that's log base 12 of 2, but it's not such a nice number. So x is approximately 0.2789429457. And so this is approximately to 4 decimal places, 0.2789. And that's your answer. Let me do problem number 48. 3 to the power 2x plus 1 minus 10 times 3 to the x plus 3 equaling 0. So let me do this. See if I can move. Okay, it's finally moving. So let me rewrite this as 2x plus 1 is just 3 to the 2x times 3. And so let me rewrite 3 to the 2x plus 1 as 3 to the x, come on, squared. So I can rewrite 3 to the 2x plus 1 as 3 to the x squared, that's 3 to the 2x, times 3, so that's going to be 3 to the 2x plus 1, minus 10 times 3 to the x plus 3 equals 0. So now I see that this, and let me actually get another page, I see that this is quadratic in 3 to the x. And so I can actually factor this as follows. I'll write it as 3 times 3 to the x minus 1 times 3 to the x plus minus 3 equals 0. So if I look at this, I'll get 3 times 3 to the x squared minus 9 of the 3x's, minus 1 of the 3x's, minus 10 of these 3x's. Minus and minus become a plus 3. So I factored it. I can use the zero factor property. See, maybe I'll pull this up, it'll look nicer. So I can use the zero factor property and set each factor equal to 0. So 3 times 3 to the x minus 1 equals 3 to the x minus 3 equals 0. Add 1 to both sides of your equation. 3 to the x equals 1. Divide by 3. Since these are equal, they have the same bases, and the exponential function is injective, I have that the exponents must be equal. I have that x must equal -1. Add 3 to both sides of your equation. And so 3 to the x is equal to, well, 3 to the 1. So again, since the exponential function is injective, since the bases are equal, and since these quantities are equal, then the exponents must be equal. And so I have that either x is -1 or +1. And that is your answer. Let me do problem number 60. Solve each logarithmic equation. Log x plus log x plus 9 is equal to 1. So let me use the property of logarithm. The sum of logs is the same as the log of their product. And so this is log of x times x plus 9. So let's multiply the x inside the parentheses. So we get x squared plus 9x is equal to 1. Well, let's write this in. And so the base is 10, the exponent is 1, and the result is x squared plus 9x. 10 to the 1 is just 10. Subtract 10 from both sides of your equation. So I get x squared plus 9x minus 10 is equal to 0. So let's factor. This is a monoquadratic trinomial. So bring down the x plus 10x, and then plus 9 minus is minus 1 equals 0. Set each factor to 0 and solve for x. So by the zero factor property, x plus 10 is 0, or x minus 10 is 0. Subtract 10 from both sides of your equation. Add 1 to both sides of your equation. Now we have to check if these both make sense, because they could be extraneous solutions. The reason that they could be extraneous is because, well, we could have that we're taking the log of a non-negative quantity. Well, let's plug in -10. What's a log of -10? Well, we don't have a log of -10, not in reals. And so this is an extraneous solution. It is a solution to our technique, but it is not a solution to the given problem. If you plug in 1, well, I can take the log of 1. I can take the log of 10. So 1 is a solution. So in this case, we only have one solution when x is equal to 1. And that's it. Let's do problem number 71. Log base 6, 8 plus log base 6x equals log base 6, x minus 2. By the properties of logarithms, I just said that log base 6 of 8x is equal to log base 6 of x minus 2. Well, since the logarithmic function is injective, and these have the same base, and these logarithms are equal, then the results must be equal. So 8x must equal x minus 2. Subtract x from both sides of your equation. So 7x equals -2. Divide both sides of your equation by 7. So x equals -7, -2 over 7. Plugging back into the original equation, we have log base 6 of -2 over 7. Well, that's not going to be a real answer. And so I'll get rid of that. This was the only possible answer. Since this was the only possible answer, then this equation has no solution. So it could be that you try to solve it, but you don't get an answer. So this has no solution. Let's do problem number 78. ln 8x minus 7 over ln x equals 2. Let's multiply both sides of my equation by ln x. Since I have a 2 in front of the logarithm, let me raise it up as an exponent. And so this is just ln 8x minus 7 is equal to ln x squared. These are equal. Since the bases are equal, then the results must be equal. So what's inside the logarithms must be equal to each other. Let's subtract 8x, add 7 to both equations. This is a monoquadratic trinomial. So let me factor to 8 into x minus 7, x minus 1 equals 0. Set each factor equals 0 by the zero factor property and solve for x. Add 7 to both sides of your equation. Add 1 to both sides of your equation. Okay, so if I plug in 7, well, 8 times 7 minus 7 is positive. 7 is positive, so everything seems to be okay. Plug in 1 into the equation. 8 times 7 minus 7, 8 times 1 minus 7, that's positive, that's okay. ln of 1, that's positive, that's okay. But ln of 1 is 0, and you don't want to divide by 0. So unfortunately, that makes this an extraneous solution. So you only have x equaling 7 as being the solution. Okay, let's do another problem. Problem number 86. Okay. Let's come on. Okay. For some reason it doesn't want to get rid of this. Okay, come on. Oh, maybe it has gotten rid of it, just not showing it. Okay, so let me do problem number 86. So the log 2 log y plus 2 is equal to log y plus 2, minus 12. Okay, so let me do this. Let me subtract log y plus 2 from both sides. So I just get the log of y plus 2 equals log minus log of 12. So I have that y plus log of y plus 2 is equal to the log of bringing up the negative as an exponent, 12 to the negative 1. And so, since we have the same base, 10, since the logarithms are equal, then since the logarithmic function is injective, then the what's inside must be equal. So I have to have that y plus 2 is equal to 1 over 12. Subtract 2 from both sides of your equation. And so y is equal to 1 over 12 minus 24 over 12, a negative 23 over 12. And let's check. Negative, ooh. So negative 23 over 12 plus 2 is 1 over 12. That's fine. So we can take the log of that. And similarly, negative 23 over 12 plus 2 is 1 over 12. So I can take a log of that term. And so this is my answer. Let me do problem number 106. Probably this amount. Okay. Something about a dead body. And that's a little bit more here. Okay, so problem number 106. So use a calculator to help solve each problem. Time of death. The exponential function t equals 17e to the negative 0.0626t plus 20 models the temperature T in degrees Celsius of a person's body T hours after death. If a dead body is discovered at 8:30 a.m. So discovered at 8:30. a.m. And the body's temperature was 30 degrees Celsius. Okay, so the temperature is 30 degrees. What was the person's approximate time of death? Okay. So we want to figure out the time of death. Okay, so first off, we have the following equation that T, the temperature of the body, is 17 e to the negative 0.0626 t plus 20. Okay. Well, I want to figure out when the temperature of the body is 30. So how long will it take for the body to decrease from 37 degrees Celsius to 30 degrees Celsius? Okay, so this is 17 e to the negative 0.0626 0.0626t plus 20. Subtract 20 from both sides of your equation. Zero point 0.0626t. Divide both sides of your equation by 10, so e to the negative 0.0626t is equal to 10 over 17. Take ln of both sides of your equation. Ln e to any exponent is just the exponent. And so this is a negative 0.0626t is equal to ln 10 over 17 ln 10 over 17. Divide both sides of your equation by negative 0.626. So t is equal to negative ln 10 over 17 divided by 0.0626. Okay. So, plugging that into my calculator, I get t is equal to 8.476 634 hours. So, 8:30 is when the body was discovered. So when did the person die? So the time of death is found by subtracting that amount from when the body was discovered. So 8:30 a.m. minus, 8 hours, so it's at midnight. So this is 0.0. Okay, 0.023, so this is hours. 1083664 o'clock. Okay, so this is, but this is in hours. So let's find what time that is approximately. Well, this is going to be this amount of time after 12 midnight. So this is going to be 12 o'clock, 12 a.m. Multiply the 0.02351083664 by 60. You get 1 minute and a whole bunch of decimals. Multiply those decimals by 60 and you get 24 seconds and some fraction. 0.63731,911. So it is approximately at 12:01 and 25 seconds a.m. That is the approximate time of death. So about